Hello again everyone, welcome back to ptet.chemistry channel. So this is Mr. On, and in this video I'll start off this introductory organic chemistry stuff that involve isomerism and etc. Well, introduction to organic chemistry. Okay, so this is just 10.1 in my classification. So in this first question, it's just basically working out total number of different chloroethane. So it looks complicated, but n can be anywhere from 1 to 6. So in this kind of question, it's best to be systematic. So when n equal to 1, then you have C2H5Cl. So realistically, you should be thinking about skeletal formula. That's the easiest to draw. There's just one possible isomer, because if you draw that, that is exactly the same. Okay, those two are exactly the same. So that's why there's only one possible isomer for n equal to 1. When n equal to 2, then you're going to get that. Then what can happen is the 2 chlorine can be on one carbon. The 2 chlorine can be on different carbon. So you have 2 isomer there. So we've got 3 so far. Alright. What about n equal to 3? Then you have C2H3CO3. What can happen is, because these are saturated carbon, so you will have heard of saturated carbon from O level or GCSE. So all the carbon are single bond, right? So meaning each carbon can form 4 covalent bond, 1, 2, 3, 4. So you can have 3 chlorine like that, or you can have 2 chlorine and 1 chlorine like that. And then you could be thinking about like 1 chlorine there and 2 chlorine there. Those two are exactly the same. So you do not count them twice, because if you name them, you have to have 1,1-dichloro. Sorry, 1,1,2-trichloro, and here is also 1,1,2-trichloro ethane. Okay, so here you have 4 and the 5th one, and you can't have the other one where you have all 3 on the other carbon, because it's exactly the same as that as well. Yeah, so technically that's the same, so I'll just circle it so that you don't miscount it. When n equal to 4, then you have 2 and you have 4 chlorine. So when you have 4 chlorine, what can happen is, well, you can fill up 3 chlorine there, and where would the 4th one go? It could go there. And then of course you can have 2 chlorine and 2 chlorine, like that. And then if you have 3 chlorine, and then another chlorine, that is the same as that. Okay, because you want the lowest number. Okay, you want the lowest number on the one where you have a lot of chlorine. So that's the same, so you don't count it twice. When n equal to 5, you have C2H1Cl5. So now what we can have is, we can have 3 chlorine on one side and 2 chlorine there. And there's only one choice, because if I go for the other one where it's got 3 chlorine on here, 2 on the other side, they're exactly the same. Alright. And of course, when n equal to 6, you just have C2Cl6. There's only one option, one and only one. Okay, that is where all the chlorine has substituted all the hydrogen, so there's no other choice. So altogether, there are 9 possible isomers that I've just drawn out all together. Okay, so yeah, I mean, it's pretty easy to actually count the same thing twice. So you need to be entirely sure and being systematic in such a way, reading the question, okay, from 1 to 6. So I think this is quite a complicated question. It hasn't come up for such a long time now. Yeah, okay. Anyway, you never know. I mean, it's a good question, right? Moving on to the next question. So this is the kind of question we can expect: finding chiral center in one molecular camphor. So we're looking for 4 different substituents, or we are looking for 4 different groups attached to one carbon. All right, you have to look for carbon sp3 because it's 4 covalent bond. So things like that you can cross out, because this one is carbon double bond, this one is a carbon sp2. Okay, so I can cross that carbon out. I can cross CH2 out because there's carbon bonded to 2 hydrogen. I can cross CH3 out. Okay, so what I'm left with now is just this, but here you can see this carbon is bonded to CH3 and CH3, so those 2 groups are the same. You need 4 different groups attached to one carbon, so that carbon cannot be chiral. And I hope you can see, if I highlight in green, this group and the purple colored group are different, left and right. Okay, so here you see the left and right are different. When you're here, you see the left and right are different. Top bit and bottom bit are different. Top bit and bottom bit are different. Okay, so this one is chiral and this one is chiral. So how many chiral centers? You will have 2 chiral center. There is one and that is another one. Okay, so look out for symmetry, and you don't exactly look at just at the next one. You look at overall on the left side and on the right side. Yeah, I mean on the left side, on the right side. Okay. So this next question comes under Introductory Organic Chemistry because of the definition of homolytic fission versus heterolytic fission. You should be aware that in a theory paper, they like to ask you to define simple things. Simple things like this could be worth the marks here. So you should know the difference between homolytic and heterolytic fission. Okay. So this one is talking about a free radical reaction. So this is a free radical reaction. I think you will learn more about this in under hydrocarbon in the next subtopic. Okay, but you have heard about substitution reaction with alkane in the presence of UV light from O level, and when you cover homolytic versus heterolytic, you will have figure out this example. All right. So the first stage of this mechanism, free radical substitution, involves Cl going to Cl radical, species with unpaired electrons. You need UV light, and this is how we show it, just with a half-headed arrow. Okay, just with a nope, I don't want that. Just with a half-headed arrow, in order to show the movement of 1 electron only to each of the chlorine. Okay, so it's equally split, so that each one of the bonding electrons go to each of the chlorine. Okay, you find out more about free radical mechanism, you can go to the playlist and look under N-level concept. Under free radical, under organic chemistry, you'll find free radical mechanism, which I explain more in detail there. All right. So we should have Cl bond is split homolytically. Okay, that is to form the free radical there. Yeah. So moving on to the next bit of the question. So this is the kind of question where we need to draw out the possible isomers again. But here you can tell it's an alkene. Okay, alkene means you have a carbon-carbon double bond unsaturation. So you would expect CnH2n, if it is just hydrocarbon, to be C3H6, but instead you have C3H4Cl2. So 2 of the chlorine has substituted 2 of the hydrogen. All right. So you got to consider structural and also cis and trans. Okay, so let's start drawing. In these kind of questions, you got to try and draw skeletal, right? If you start drawing display formula in multiple choice questions, in fact, if you start drawing display formula in all of your organic questions, you are going to end up in so much trouble. Okay, only draw display if the question asks for display, yeah? But you got to know what display formula means regardless. Okay, so if I start drawing skeletal, so we don't show the hydrogen bonded to the carbon. I have an alkene, all right. I have an alkene, 1 carbon-carbon double bond. I have 2 chlorine. Where can I put the 2 chlorine? I can put the 2 chlorine there. That would be 1, 2, 3, because you want the lowest number on the alkene. Okay. Wait, hang on. Nope, that is not true, because now that you have halogen, you want a 1, 1. You want a 1, 1 dichloro. 1, 1 dichloro. This is a prop. It's a prop 2 in. If I had gone for the one just now, I have prop 1 in, but I have 3 dichloro, and that is quite a big number. You want the smallest number for your important group as well, yeah? So I'm not going to do naming for all of them, but I'll just showing you there, yeah? So now you also have 3 carbon like that. So where else can I put the 2 chlorine? Okay, so I'm trying to put 2 chlorine together first, all right? If I have 1 chlorine there, I cannot have 2 chlorine there, okay? So I don't want that. I want 2 chlorine. So that could work. Okay, so it's a 1, 2, 3 carbon. There is a 1 hydrogen, 2, 3, 4. Okay, so there is C3H4Cl2. All right, so there's 2 chlorine together. So there's 2 chlorine together. And I cannot have cis and trans here because you have 2 groups that are the same on the carbon. On the same carbon, you have 2 groups that are the same on the same carbon bonded to the double bond. So you cannot have cis and trans there. So no cis trans there. So now what else can I have? I can have 1 chlorine and I can have another chlorine there. Okay, so chlorine separated now. Okay, so chlorine are separated now. I can have cis and trans now because that is trans. When you see this group is opposite to the other major groups, okay, because this is just hydrogen there. So this and this are opposite to each other. What else? You could have that. That is the cis, all right, where the chlorine and the CH3 are on the same side, okay? So I'm not talking about this. I'm talking about on the different carbon. You have a chlorine and a CH3 on the same side, yeah? So now we are looking at a chlorine separator, right? So here they are next to each other. How about if they are not next to each other? 1 there, 1 there, okay? Of course, then you could also have, oops, sorry, I forgot to count that. So there's 4. So that should be 5. There should be 6. So when the chlorine are not together, you could also have, when the chlorine are not together, what else could you have when the chlorine are not together? Oh yeah, there's one of it. So there's a 1, 3. So here is 1, 2. Here's 1, 2. Here is 1, 3. Okay, 1, 2, 3. What else could I have? I could also have the same deal like that. And that is different from this and this. Yeah, because the chlorine are separated from each other. Okay, are they the same from anything before? No, they are totally different, okay? So the 2 chlorine are separated. The 2 chlorine are separated, but here they are both on the double bond. Here they are not on the double bond, okay? How many am I looking at? 6 already. I forgot, this one can also show you cis and trans, because that is showing you on opposite sides. So that is your trans. Of course, I can draw the cis. There's the cis. Okay, so there is the cis isomer, which means this is 7, which means I already reached the maximum, which is 7. So see how easy it is to miss, okay, if you don't count the cis and trans, okay? So the question specifically asks you to count the cis and trans, okay? So I hope that was useful to some extent. You just gotta be systematic and try not to miss anything, okay? And obviously read the question. Do they want structural, cis trans? Do they want optical? That kind of thing, yeah? All right. So moving on to the last question in this 5-question series on introductory organic chemistry. This is more questions of this type. You got to draw skeletal. They want both structural and stereoisomers. We are looking at C4H10O. So the more carbon you have, the more complicated it becomes to start drawing display formula. Yeah? It doesn't make sense at all, all right? So we're looking at alcohol. So because they say alcohols, so something like OH, 1, 2, 3, 4, 4 carbon, yeah? 1 hydrogen, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, carbon from 4 bond. So there's the straight chain. I always start by looking at the structural first, all right? Straight chain. So now what can I do? I can have 1, 2, 3. So just now I have 1, 2, 3, 4. When I have 1, 2, 3 in the longest carbon chain, I have a branch. I can have a branch at position 2. I can have a branch at position 1. Okay, they are different. Branch at position 1, branch at position 2. In fact, this won't be 1, 2, 3 anymore. This will become 1, 2, 3, 4 in the new numbering scheme because you want the longest carbon. Okay, you want the longest carbon when you start naming things, yeah? Anyway, it doesn't matter. Okay, they're not asking for names here. I hope you also realize that this is chiral. The carbon here is bonded to 4 things. There's a hydrogen which is not shown. There's a 1 carbon. There's a 2 carbon. There's a OH. So there's times 2, okay, optical isomer. So you have to count them 3 and 4, okay. Here you don't have a chiral carbon because, well, the carbon here is bonded to 2CH3. Here you don't have a chiral carbon because it's CH2, 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 CH3. Okay, so I'm going to have to count it from number 5. So there's 3 carbon. How about when I just have 2 carbon? So just like that. Then where can the 2 methyl go? Well, if I just have the 2 carbon, then the 2 methyl can be like that. Branch out like that, CH3, CH3. So here this is a tertiary alcohol. This is a primary alcohol. This is a primary alcohol because the carbon with the OH is bonded to one other carbon. The carbon with the OH is bonded to one other carbon. The carbon with the OH is bonded to 1 and 2 other carbon. This is a secondary alcohol. The carbon with the OH is bonded to 1, 2, and 3 other carbon. This is a tertiary alcohol. Again, there's no chiral carbon here. Yeah? There's no chiral carbon center there. I'm just thinking, what else can I have? Can I have any other possibilities? I think that's all really. I've got all 5 of them. So straight chain, branch chain. There's only one tertiary alcohol because then that will give me 1, 2, 3. So this one will be called propan 2O, and it's a 2-methyl because it got a CH3, which is the methyl at position 2, 2-methyl propan 2O. And yeah, it should be all 5 of them there already. I don't think I've missed anything. This is the straight chain, this is the branch chain. I didn't miscount the optical isomer. There's no chiral center in the other one, so there's only 5. Okay, so we reached the end of this short tutorial video. I'll see you in the next video on more of this tutorial into multiple choice question, which I think are really good practice to get you thinking about what kind of things can come out in theory as well. Yeah, so for me, multiple choice is a very good revision for your AS theory. Okay, so please subscribe to the channel if you haven't, and spread the words about the channel so that more people can benefit about it. Okay, thank you for watching.